Hello, my name is Suminder Puri. I'll be giving a presentation on cloud computing and the security issues related to it for Network Capstone TDC 594. So overall, I'll be going through cloud computing on how it works, what are the different types of layers, what different type of services that you use for the cloud computing, and what are the factors of security that is laying it computing a little bit back, or the customers are being hesitated to use this service. So some of the security issues related to it. So let's take a look. First of all, just take a look at the how people concerns about cloud computing. As you can see in this graph, people have been searching a lot for cloud computing in Google since 2007, especially since the first month of 2009. And there are different kinds of computing, which is grid computing and the cluster computing. Grid computing has been falling greatly, and the cluster computing is still the same for years. So definitely we can see the people are getting more and more towards cloud computing and accepting the cloud services. They also at the same time, cloud computing also attracts a lot of attentions of media, news, and they're still growing of the time. We can see they are now more and more into the outside world, and people are getting more aware of the cloud computing, what it is and how they actually works. So people wants to know more about cloud computing and the services they've been offered. So there's some forecast of the cloud future. By 2011, it's the market is almost reached 40.7 billion. They've been predicting by 2014, 2 out of 5 firms will pay for cloud services. And by 2020, the cloud computing market is expected to be $241 billion market. So we can see how the trend is not changing, how the people are going more towards cloud computing, and they're getting more and more aware, and how in the future it's been expected to reach 241 billions. Here we see, as look at the history, if we say the cloud computing is the 5th generation of computing after monolithic client server, web, then service oriented architecture, and now it's cloud services. So definitely by 2009 it has been reached to the market, and people are now going more and more towards cloud services. We don't know what's the next generation. Maybe it's the computing and computing. Computing is not about computing anymore, it's about living. Definitely when we say this, it's mean a lot, because everything is now dependent upon how available your infrastructure is, how scalable it is. If you want to change something, how without even changing the whole infrastructure, how your services you want to achieve, everything is there. So definitely it's not about computing anymore, it's about living. But what is cloud computing? I would say cloud computing is a platform that for the users or clients to access computing services which is independent of hardware or use of physical location. It overcomes the need to store information on the PC or any other gadget, assuming that the information can be quickly accessed through the internet, thus which helps in eliminating the use of installing the softwares just through the web browser and storing or accessing the softwares on your own computers or office computers, which in turns help in freeing the memory and also reduces the cost to it. So that is one of the prime factor that people are more attracted towards cloud computing, as they have to pay for the utility and they don't have to care about the software, installing the software, about the hardware, and which in turn help them in freeing the memory, and thus which helps in reducing the cost by saving the power to it. So this, I have to say that there is not any formal definition, and you can find out like there are different definitions of cloud computing out there. So here we took the definitions of Wikipedia throughout the time since 2007. You can see people define cloud computing quite differently throughout the evolution, and it's still changing. First, it has been called as cloud computing is a computing paradigm which shifts where the computing is moved away from the personal computers or an individual server to cloud. Now it's been called as cloud computing is an example of computing in which dynamically scalable and often virtualized resources are provided as a service over the internet. So there is no proper definition to it, but still people know what cloud computing is. It's been changing, and maybe by 2000 14, it will be having more advanced definition. So it's the approach to this cloud computing from the people perspective is changing day by day. Here this is the characteristics I defined. Simply I can summarize some characteristics of cloud computing. The first characters that build up the word cloud, just I made it using their usage, and so it's very easy to remember. They're like common, location independent, they're online, they're utility, and demand utility implies, the demand implies. So definitely it's location independent. You don't need to worry about the infrastructure. Don't need to manage. It's online. You can use it anytime you want it. Utility is simply you pay for how much you use it. Demand, it's how much you demand the service on demand. You get infinite, immediate, the scalability, like there is no proper design that you have to get stuck on when you build an infrastructure. You can always change it according to your requirements. That's the most amazing part of cloud computing. They're like infrastructure is totally programmable. They are like on demand, self-service, pay as much as you use. Like applications are composed and can be built on different infrastructure. The services are delivered over the network. So what are the different types of cloud providers that's it's there in the outside business? Amazon, they provide a great service of web services. There is a Google App Engine that provides a platform as a service. They provide each of the vendors which is there outside provide specifically each of the service, which we'll take a look later on. They provide each of the service as their own specialty. There's Windows Azure, there's Salesforce.com, there's Rackspace, which also provides infrastructure as a service. There's SurfPath. So there are different cloud providers, but we can say Amazon right now is the most giant in cloud computing, providing the services of infrastructure as a service. So basically there are three types of models. There's public cloud, private cloud, and the other type of that mixes the public and private is the hybrid cloud. Public cloud are run by, you can say, third party, or the applications from different customers are likely to be mixed together on the cloud servers or storage system and networks. We'll discuss it in the security aspect of virtualization, in which different customers are likely to be mixed together as they use maybe services on the same computer, but they're being isolated from each other as being virtualized. The public clouds are most often hosted away from the customer premises, as they provide way to reduce customer risk and cost by providing a flexible, even temporary extension to enterprise infrastructure. Then private cloud are built exclusively for one client, providing the utmost control of the data. They know how to change it. They have over control over the whole enterprise. They want to build it over the security, over the quality of service. The company owns the infrastructure and has control over how applications are deployed on it. Private clouds may be deployed in an enterprise data center, and they also may be deployed at co-location facility depending upon their requirements. Hybrid clouds combine both public and the private models. They can also help to provide on-demand and scalable externally provisioned scale. They have the ability to mix this private cloud with the resources of a public cloud and can be used to maintain service level in the face of rapid workload fluctuations here. So definitely if the company is using their own infrastructure, but at the same time they want services for more advanced scalable service, but they don't have the infrastructure or scalability to their own enterprise, they can always go for the public cloud service, and that is what they use, the both type of service, and that's what it's called as hybrid cloud. And do it. So after this type of cloud, like we will discuss now what are the basic architectural layers of cloud computing, how it internally works, what are the layers on which this cloud computing depends, and on which the other companies or vendors offer their service depending upon these layers. So let's take a look. Software as a service. This is kind of a diagram that I made according to my understanding of suppose any end user is trying to access it, so how it goes through access to the data that he wants to use. Basic software as a service features a complete application offered as service on demand. A single example software that runs on the cloud and service and multiple end users or the client users, so it's not sure like only one user uses it. Without even we knowing it, there will be a multiple users which will be using at the same time that service, but it is being offered to single person or a client or to a single client without they be knowing that these services are offered maybe to the different persons also, which is running on the same machines. So here we can just take a look, like the application has been previously deployed by the SaaS vendor and is available on demand. So we tell them what we needs to use it, and they do everything for us. We just need to go and use the service and just pay according to the service we use it. So there are plenty of companies that provide the software as service. Example like Salesforce.com. There is a Google Doc. There is a Clarion. So there is a company which gives pretty much services of a software. The next one is platform as a service. Here I just made a diagram according to that. Platform as a service, basically it encapsulates a layer of software and provide it as a service that can be used to build higher level services. So someone suppose producing PaaS might produce a platform by integrating an operating system or middleware or application software and even a development environment that is then provided to a customer as a service. Someone suppose using PaaS would see an encapsulated service that is presented to them through this application package, or which is presented through API. The customer interacts, basically customer interacts with the platform through the API, and the platform does what is necessary to manage the scale itself to provide a given level of service. So here we see is there's an application package which is basically is deployed by the software owner whatever we requested, and we use a service. So for platform as a service, there are companies which provides these applications that are Google App Engine, Windows Azure. So here a platform as a service basically which gives the software as a platform. We need to install or request whatever service we want to use it. That's our responsibility, and they give you whole infrastructure to use it, but all the application and usage are depend upon us. So next is like infrastructure as a service, which delivers we can say the basic storage and compute capabilities as standardized service over the network. Servers, switches, routers, and all the equipments are pooled and made available to to handle workloads that range from application components to higher performance computing applications. So here we can they give us all the platform to use it as an infrastructure. We know like routers, switches, everything we need to deploy. So the major chunk of services that the companies that provide these services are Amazon, which provides the Amazon Web Service. There is a Rackspace, there is a SurfPath, which gives these kind of services. So here is the overall. I just build it as architecture on how to show the layers, how it works, in which the it works as the basic cloud infrastructure is like infrastructure as service. If you want to use is the most deeper level, then there is platform as service, then there is a software as service, in which all the three is used. If you want to use explicitly the infrastructure as service, there is the most deeper layer. But when you use as software service, you basically use a platform as service also, infrastructure as service also. So here I have just put in a graph showing economics of cloud computing versus traditional IT, including this capital expenditure and operational expenditure. The cloud computing users can avoid these capital expenditures or hardware, software, and services, and when they pay a provider only for what they use. Consumption is basically usually built on a utility, which is resources consumed like electricity, right, or subscription. So it's kind of a newspaper. The amount of a service we use it, we pay for it, basically with little or no upfront cost. So that was the little comparison with the traditional IT with the cloud computing services. So let's take a look the next, the pros and cons of this cloud computing. We can see the scale, positive is like scale and cost, encapsulated chain management, next generation architecture, choice and agility. Definitely we have this as much as we use, we pay for it. Scale, I mean, it's scalable. It's you can use a simpler level service, or you can go to the high range as want to use according to your requirements. There is a proper change management. You want to change some service, they're highly equipped, and you can use it anytime you want it. You get the high infrastructure, the latest updated models of all the services that you want to use. You have choice and agility. Whatever you want to use, you use it. It's nothing we call as we are stuck. If we are using as enterprise or services on our own, we are stuck to this particular infrastructure. But here we have a choice. We have agility to move from what service we want to any extent. Then there's a cons or negatives that is affecting cloud computing in a negative way. It's like reliability, how much you rely on their services, how much you have faith on them, how much secure you are. Is it like 100% proof they are giving you 100% assurance of your data, which is stored on the third-party hardware? You don't know where it is located. Are they giving you guarantee of integrity? You don't have control over the data because it's being stored in third party, which is what are the services they can give you? Are they giving you confidentiality? Are they giving you integrity to maintain your data? So these are some of the questions which are coming to the con side of the cloud computing. So now let's take a look, like what are the problems. Like, you can never control everything in cloud computing. There will be always two problems: your problem and their problem. Here in software service, we have our storage. That's our problem, but everything else is their problem. Application server, middleware, database, operating system, CPU, networking, backups, all the data center is their problem. The only thing that we need to concern about is like our data, which is storage. In platform as a service, we have problem as our application. What application we want to use it, it's our responsibility. All the other things is their responsibility. We don't need to bother about anything which is related to equipment or application server or database. It's their responsibilities. So these are some things that is offered in platform as a service. In infrastructure as a service are having a problem, which is application, our application server, our middleware, our database, our operating system. Everything is dependent on ours, and what they are dependent with, which they are dependent, is like hypervisor, CPU, networking, storage excuse me, storage, backup, data center, everything. They are responsible for that. That's their problem. We don't need to care about it. So we can see like each of the servers have their own problems in which the company is responsible for something, and the owners or customers are responsible for some of the things. Now this is the overview of cloud computing, like governing the cloud and operating the cloud. Here we're concerned is how they're operating in the clouds, the traditional security, data center operation. These are some of the things that we have to look into. So let's take a look about the security aspects we need to concern about. data center operation, how much we know about how they're operating in our data center. Do we actually know how our data being processed? Do we know actually who are the persons responsible for data? Who can we rely on them? That's how the operation of the data center works. We don't know. This is one of the one thing in securing the cloud computing. Storage, where are data being stored? We don't know anything about it. Like, where are our data? We are not sure where it is being stored. Then virtualization. This is one of the a major, I can say, point which is affecting cloud computing in terms of security. What is like virtualization? Virtualization basically is like allows the pooling of, we can say, a computational power and storage of multiple computers, which can then be shared by multiple users. If I were to give an example, like suppose the cloud computing, a business can lease computer resources from a data center to operate websites and interact with the customers. And without even having have to pay for the overhead of buying and maintaining their own infrastructure. The virtualization manager, which is commonly called as hypervisor, is a type of software which creates a virtual machines that operates in isolation from one another on a same computer. In other words, I would say the hypervisor allows different operating systems to run in isolation from one another, even though each of these systems is using computing power and storage capability on the same computer. So this is one of the major threats to virtualization and cloud computing, like is malicious software that enables computer versus, or the malware that have to compromise one computer system to spread the underlying hypervisor and ultimately to the system of other customers. In short, a key concern is that one cloud computing customer could download a virus, such as one that steals user data, and then spread that virus to the system of other customers. If this sort of attack is visible, it undermines the consumer confidence in cloud computing. Like there is still they are working on to secure this hypervisors, and they have developed the software which provides security to its call as HyperSafe. Like for malware to affect the hypervisor, it typically needs to run its own code in the hypervisor. HyperSafe utilizes two components to prevent that from happening. First is called HyperSafe program, which has a technique called non-bypassable memory lockdown, which explicitly and reliably bars the introduction of new code by anyone other than the hypervisor administrator. The second, HyperSafe uses a technique called restricted pointer indexing. This technique initially characterizes a hypervisor's normal behavior, and then it prevents any deviation from that particular profile. Only the hypervisor administrators themselves can introduce any change if they want to the hypervisor codes. Still, after providing these kind of security to the virtualization area, it's not 100% foolproof guarantee like sure it is being provided against the attacks. And this is one of the reason that cloud computing is affecting with the virtualization managing softwares. The second type of security that concerns is like encryption and key management. Cloud computing changes the way we think about computing, like by removing the specifics of the location from its resources. So it abstracts all the computing and network resources. However, we would say components from the location. This creates security issues that result from this lack of any boundary. In these kind of situations, there is only one way to secure computing services, all the resources and services, which is having a strong encryption and scalable key management. For a risk management perspective, if you take a look, unencrypted data existing in the cloud may be considered as lost to the customer. So application provider who are not controlling this backend system should assure that the data is encrypted when being stored on the backend. So using encryption to separate data holding from data usage is the key that one wants to control. And if we segregate the key management from the cloud providers hosting the data, creating the chain of separations, these things protects both the cloud providers and the customers from being conflict when they're being compelled to provide data due to some any legal issues to potentially like solve some problems. So definitely this is encryption is kind of adhering to the existing industry or government standards that they one wants to make it as as a strong, we can say, a management. This is one of the this is the thing that I showed just a graphical way, showing how the key management, the encryption on the transmission is taking place. So to explain more of this encryption and the key management, I have taken an example of Amazon, Amazon Web Services, how they basically works and what they do for securing this web services. So we'll just take a look. This is what they provide with the efforts to do there for the security. Amazon basically provide two kind of services. They provide cloud computing services and support services, which is simple Amazon Simple Storage Service, Elastic Compute Cloud, Simple DB, CloudFront, Simple Queue service. They provide Amazon Flexible Payment Service, Amazon Mechanical Turk. So these are and how the integration is there between these two kind of support services. That's one of the you can say major secure lying area, like how they integrate these services together without being compromised with their security services. So let's take a look. When you go and register to apply for the web services, you get the access key ID. Your access key ID identifies you as a party responsible for service request. You use access key IDs as the value of AWS access key ID parameters in request you send to the Amazon Web Services when required. You get a secret access key. Each access key has a secret access key associated with it. You use your secret access key to calculate a signature to include in request to the web services that require authenticated request. Your secret key is a secret and shouldn't be known by should be known only by you and AWS. You should never include your access key in your request to AWS, and you shouldn't even, that's one of the like thing that one can restrict, like by you shouldn't disclose it, never email your service key to anyone. So it is important to keep your secret access key confidential to protect your account. Then there is one more access key rotation that is being provided by Amazon that supports multiple concurrent access keys. This allows you to rotate keys without impact to your application availability. AWS always recommends that one should always rotate keys on a regular basis. To rotate keys, just need to create any when you access this account, you need to update your application to use the new key and then deactivate or delete the original key. So there has been provided the security with registration and security by AWS. What the X.509 certificate consists, it basically consists of the public key and the private key. The file containing the public key, the certificate file, must contain a base 64 encoded DER certificate body. The file containing the private key file, must contain base 64 encoded PKCS #8 private keys. The private key is used to authenticate request to the AWS. So AWS accepts any syntactically and cryptographically valid X.509 certificates. They do not need to be from the formal certificate authority. They can provide all that certificate service by the Amazon. They provide for their securing the services. Now, this is multi-factor authentication, is an additional layer of security that offers enhanced control over your AWS account settings. When you enable this opt-in account feature, you'll need to provide a 6-digit single-use code in addition to your standard AWS account credentials before you get the access granted to the AWS settings. You get this a single use code from the authentication device that you keep in your physical possession. This 6-digit code is generated when you log in and through the servers. You get this 6-digit code to your the device that you have in your physical possession. This is called as multi-factor application authentication, because 2 factors are checked before access is granted to your account. You need to provide both your Amazon email ID and password. That is kind of first factor. And the other one is precise code from your authentication device. This the second factor. That's something we have it. So this is something that I showed with the help of Amazon, like when you create a request, what we do it and what they do it. When we create a request with the help of access key ID actions, they create a HMAC, which is a HashMac authentication code as an SHA secure hash algorithm. They can use any type of service. They can use HMAC and MD5 also to build a signature. So they basically use SHA and HMAC for the signature. What they do is say, based on the request contents, your secret key, there is a calculation through which it generates your own signature. And this signature is then sent to AWS. And what AWS do? They retrieve your access key, secret access key, and then they that secret access key, with that they perform their calculation, their HMAC calculation and encoding, and they the signature is calculated by the AWS. And then after both the signatures are being done, they're being compared, and if they matches each other, then the request is authenticated. Otherwise the request fails for the authentication, and you need to again log in and have to go through each step that we just showed. What is basically the use in this HMAC calculation and encoding? In cryptography, a key hash message authentication code is a type of like message that helps in calculating a specific algorithm involving a cryptographic hash function in the combination of secret key. So an iterative, we can say, cryptographic hash function, they can use anything like MD5 or SHA1, which basically Amazon use SHA1 for the calculation of HMAC. This SHA hash function are cryptographic hash functions, which is designed by the National Security Agency and being allowed by the NIST, a National Institute of Standard and Technology, and as a US Federal Information. So SHA basically produces a 160-bit digest from a message with a maximum length of 264 bit. So basically this is a type of calculation that Amazon use it for their security purpose. Still, after providing these kind of authentication and multi-layer authentication service security to the consumer, still they don't take that responsibility. They when you sign the agreement with them, they will say that you are solely responsible for configuring and using the server, offering and taking your own steps to maintain appropriate security, protection and backup of your content, which may include the use of encryption technology to protect from content from unauthorized access and routine archiving from your archiving for content. So This is something that you need to look at, that they don't want to take the responsibility for their encryption also, and when you sign the documents they will give you this as in your signing part. So you can see even after providing so much of security levels, they are not sure if it's full 100% secure and all the data will be intact with them without even bothered for any malware or any outside intruders can attack to it. So we will now take a look like on how much before investing all the money, how much you trust them, how much you trust the inside access users, how much you trust their ownership. Are there some questions that need to be answered? How much it's available? They say it's highly available, but how much? What if something goes wrong? If there is some outage or there is some denial of service from the vendors, then you are also stuck. So there are some of the questions that we need to answer, and these are kind of 7 things that I noted that a customer should know before investing their money into the cloud computing, which is like privileged user access. Ask providers to supply specific information on the hiring and oversight of the privileged administrators and the control over the access. You need to know who are the persons responsible for your data access. Regulatory compliance. Customers are ultimately responsible for their security. That's the thing that the providers who refuse to undergo the scrutiny, when you ask them like what are the major responsible for the scrutiny and integrity of your own data, are like signaling that the customers can only use them for the most trivial functions. So this is one of the things also that you need to ask providers specifically about it. Data location. When you use the cloud, you probably won't know exactly where your data is hosted. In fact, you might not even know which country it has been stored. So we need to ask providers about these things, and if they're willing to commit to storing and processing data and according to our requirements and where we want to do it. Data segregation. Excuse me. Data in the cloud is typically shared environment alongside data from other customers, as we discussed in virtualization. On one computer also, maybe there are multiple customers using different services. So encryption is kind of effective, but isn't a curable, like cure-all, we can say, to this. Then find out what is done to the segregate data at rest. The cloud provider should provide evidence that encryption schemes were designed and tested by the experienced specialist. Because encryption is something that accidents can make data totally unusable, and even normal encryption can complicate the availability. So these are some of the things. Then there is a recovery. What if you don't know where the data is? Cloud provider should tell you what will happen to your data in case of a disaster. Any offering does not replicate the data and application infrastructure across whatever multiple sites it is due to failure. They need to tell you what if something goes wrong. Investigative report. Investigating inappropriate or anything illegal activities from the inside users, or because cloud services are especially difficult to investigate before logging and data for multiple customers, which can be co-located and may also be spread across ever-changing set or maybe data center. So if you cannot get the commitment to support this specific form of investigation, you are need to concern about these facts. What's the long-term viability? Ideally, your cloud computing provider will never go broke or acquired, or suppose it get acquired and swallowed by something, maybe major large company. So you need to assure your data will remain available even after such kind of incidents or events happens. We need to ask potential providers like how you would get your data back if something happens. It will be in format and you could import or replace all the applications to it. So these are kind of 7 things that I discussed that one customer or need to ask the vendors about it before investing their money. So I would summarize this cloud computing as cloud computing is like becoming more and more popular, but cloud computing security is really important problem that everybody or company which goes to use cloud computing should be concerned with. There are some of the issues, but the all the advantages that provided by the cloud computing is something inevitable, like it's invaluable, providing the service as you want to use without even caring about the infrastructure you pay for. So there are some of the things that they still attracts the customers, and they are increasing rapidly. That's what I would say about cloud computing and the security part. Here are my references from where I got the information is Wikipedia, security. I'm thanked to Amazon, National Institute of Standard Technology, the Cloud Computing Standard Roadmap. From these are the references which I got to know about it. Thank you. If you have any questions regarding this cloud computing which I gave you as my presentation on security, please do email me and let me know what are the questions, so I'll be happy to provide you with any kind of queries with my presentation. Thank you. Thanks a lot for hearing.